All right. So, on a normal, this is a quick review. If this were a sine or a cosine, what does that -2 represent?
Up or down.
So you're up or down, which we call our vertical shift. So I would go to -2, put a dotted line. Is there any difference between sine and tangent in that regard from what we said on Friday? None. So I can still, whether it's sine or whether it's tangent, and I'm on that number 3, we graphed sine and cosine, I'm on the tangent graph. So that part's the same. I can go to -2. We call that the D value or the vertical shift. I'm not gonna probably ask you, what is the name of it? But I may say, what is the value of the vertical shift? And if I do that, you'll have to be able to tell me it's -2. So that is my D value, which was -2. Is everybody with me on this?
No.
No? It's not your page 117. I continue to add stuff.
It is.
It is 117.
Oh, it is?
I was
Okay.
on a different one.
Okay. Yeah, sometimes my page numbers won't match yours because I print yours 2 months ago, and then I continue to change it and add it and modify it. So that's your D value, right? And then that part's not different on any of the 6. And then the -2, what did that stand for with sine and cosine? That was with sine and cosine was your, what do we call that value? I'm sorry, not the -2, the +3.
The A.
The A value, which was the amplitude, and we said when you label amplitude, it's always positive. But we don't really call it amplitude here because amplitude is kind of like a wavelength, and it's talking about height, and height or distance is always positive. But in this, because it goes up forever, it's not really the amplitude, but it's still going to be marked because we're going to use it, and I'll show you how to use it in a second. So I'm still going to mark that the exact same way I would if it was sine or cosine. So I'm going to go from the D value, up 3, down 3, and I'm going to mark that. And I don't have to look at that -2 or that +3 again. So again, we're graphing a tangent curve here, but I put sine there just to show you that it's the exact same thinking either way on those 2 values. What was the third thing we marked if it was sine or cosine? Not the vertical shift, but we didn't really call it that, but it is kind of a shift left to right along the horizontal. We called it rhymes with haze. Phase shift. All right, so we call that the phase shift. And how do we find the phase shift? So we took this essentially, set that part equal to 0, subtracted this, and then we also said, so we don't make this careless error. If you want to look up here, I see people every year, they divide by 2, and then they cancel that 2 out, like they cancel that 2 out, and they say x equals -pi. This is terrible, right? If I have a half of a pi, and I divide it amongst you 2 people, do you really get a whole pi? No, you're going to get 1/4 of that pi, right? So, but it's very easy to make that math error. To avoid that math error, it might be easier to say multiply by 1/2. And you can still see it cancels there, but you can see here that it does not cancel. Leaves you -pi/4, so I'm going to go to, and that's going to look different on every number line. On this number line, pi represented 4 ticks, so I'm going to -1/4 of that. So if that's pi, -1/4 would be -1 tick to the left. And that's a location, right? But if this had 8 ticks, I'd be moving 2 ticks. It just depends how many tick marks make up a pi. So I'm going to go to right here. But here's the difference here. This is my phase shift. And on tangent, if you think about the notes that we had, or if you remember this from last year, instead of having a box, the box thing that we used to graph sine and cosine, it's going to have vertical asymptotes here and here. And it kind of looks more like a ladder than a box. And then tangent, unlike all the other 6, the phase shift is not the beginning. What did we say about it? I think we mentioned this on Friday. The phase shift marks the middle of that period. Now somebody asked me in seventh period, they said why? Well, the why, remember, we're just looking at patterns here. We're trying to find some patterns to make it easy for us. What's the real reason why these things look like they look? What's the real reason why any graph looks like it looks? When I plug what? When I plug numbers in for x, it spits out values for y. So when I start plugging in these numbers for this x, I'm going to get points like right here and right here. And it's going to end up looking, I'm going to go back to tangent now. It's going to end up looking something like this. That's why it looks. I'm just trying to find U patterns. I think we did that with the sine curve. We punched in a bunch of values and you saw that it was starting to make a sine curve. I don't want to do that every time I graph one of these. It's just awful. So what I'm going to do is just notice patterns. And in noticing these patterns, the way I think through it is the phase shift is going to mark the middle of the period on tangent only. So when I mark that phase shift, I am not going to put a dotted line up and down. Because if I do, what's it going to end up looking like? If I put a big dotted line where the phase shift is, I very likely could confuse that with a vertical asymptote. So what I'm going to do is I'm just going to mark it with an arrow. Now on all the other graphs, it is the beginning of the period. So I can put a dotted line there to kind of mark the beginning of the box or the beginning of the ladder, but not on tangent. So there's my phase shift right there. I'm going to mark it. And then the last thing I need is what? The period. Now normally I find the period, if you look up here, I find the period and I mark one period over to the right. And then another period over. And since I'm only graphing a couple of them, I usually call it quits. Or you could go one to the right, one to the left, or two to the left, doesn't matter. But if the phase shift is in the middle of the period, splitting it in halves, when I find that period, what do I have to do to find these asymptotes? Come forth with words. What do I do? If the phase shift is in the middle, and I've already found it, and I'm about to find the period, when I find the length of that period, how do I use it to find the asymptotes? Go half each way. Right? So, what's the length of this period? And we said tangent and cotangent are the only two that work this way. All the other ones were 2 pi over b for the length of the period. But what's the length of a tangent or cotangent? Pi over b. And all these are in your notes a couple pages earlier. So pi over the b value, in this case, is pi over 2. And you remember, it's a length. So how many tick marks on this particular number line, or this ruler, is pi over 2? 2 ticks. So if the whole period is 2 ticks because of this pi over 2, then I want to go half a period that way and half a period that way. So I'm going to go 1 tick to the right. That's my asymptote. And 1 tick to the left. And that represents a total of 1 period. And if I had marked that phase shift with a dotted line, it would have just totally kind of confused me, or potentially confused me, because it almost looks like there's another vertical asymptote. Now at this point, if I need another period, which you do, I'm always wanting you to graph 2 if you can fit them in there. How do you find that next period? I mean, how do you mark off that next period? So how many ticks to the right? 2. Yeah, don't do this. I see people every year. Another half and another half. No, once we get it, right, then just mark off another whole period. Now, do you see the ladder in there? So there's the rungs of the ladder. It's going way down, way up. And then on tangent and cotangent, I know we haven't talked directly about cotangent yet, but on all of these, what point gets marked here? On all these ladders, what point gets marked? Dead middle. So I can always go to right there, and that's true whether it's tangent or cotangent. So I'm going to go right dead to the to the middle rung, in between the asymptotes, mark that point. And then what do we say about tangent? For a positive tangent, it's all right, so I know I'm going up to the right and down to the left. And if it was positive, if it was negative tangent, I just switch it. And then if it's cotangent, it's all left to be cut or cut to be left or whatever. And then if it's negative, it switches. But don't confuse, we said this, don't confuse a positive tangent with a negative cotangent. Every year there's somebody who goes, oh, negative cotangent. Those end up going up to the right. I'm just going to change that to a positive tangent. Because if you do that, you'll get the right look, but what will be different? What's different about tangent and tangent only? What did we say? I know we haven't technically done cotangent since last year, but what did I just say was different about the tangent? The phase shift is marked differently, right? All the other ones, phase shift at the beginning. Tangent, phase shift in the middle. So if you just take a negative tan and go, oh, those look the same as a tangent, and change it to a positive tangent, then your phase shift is going to be off, because a negative cotangent doesn't have a phase shift in the middle. It's phase shift at the beginning like all the other trig functions. So don't do that. Although I will say, once you get the ladders drawn, if you see a negative tangent, yeah, that's going to look like a tangent based on this. Now, where do the amplitudes come in? Because right now you're probably tempted to go, oh, point in the middle, up to the right, and just sketch it. And you might get lucky. But the amplitudes come into play like this. If I go halfway between that middle point and the asymptote, just like right there, or halfway between here and the asymptote right here, the amplitude is how high or low you go at that value. So if this is a positive tangent, which is up to the right, you can go halfway between the asymptote and that middle point, and then just go up to the A value, and down to the A value. So it is the stretch, but it's the way you mark that stretch is right there at that value. And at this point, guys, don't try to, I see people right here doing all kinds of I'm going to do something weird here. I see people doing, okay, it comes down here, and then does this. And they get all kinds of weird things like this. Dude, think parabola. On one side, upside down parabola on the other. So like right here, if you're coming down, think, okay, I'm just coming down smoothly. It's kind of like it would be a parabola and then go up, but it's just a parabola and then it goes down. So there's a lot less wiggle there than you might think, unless the A value is really small. Like, what if my A value is right here? If you want to look up. If my A value is right here, you're coming down, and you're thinking, okay, it's going to bounce, but it doesn't bounce. It just turns and goes back through. So unless the A value is really small, like 1 or a half or a fourth, you get very little wiggle. Most of the time, it just kind of looks like a gradual, slow moving curve right through there. But this A value was 3. So when you mark that 3 there and that 3 there, you're going to see very little curve through here. And again, as long as you mark those 3 points, I give a lot of grace in the drawing, because I realize we're not all artists, especially mathematicians. There's probably a correlation between your mathematical brilliance and your bad handwriting. You know? Not always. There's some college professors that actually draw wonderful pictures. Sometimes they're 3D drawings. I was like, nice. But most of the time it looks like a doctor's prescription, you know? Y'all with me? Well, that's tangent. So the main thing you need to remember about tangent, cotangent, are the periods are different. All the other ones, 2 pi over b. Tangent, cotangent, pi over b. And then the one thing to remember different about tangent than all of them is the phase shift is the middle. So you're going to have to go a half a period each way. Now, a lot of times I'll give you a picture like this. I'll give you an equation like this and say, give me an equation of an asymptote. And I'm not going to ask you to graph it. And most people are like, oh, the asymptotes, yeah, that's at the beginning of the period, and they find the phase shift. But you can't do that. You can find, pretend we were not graphing this, and you found the phase shift, and you're like, okay, phase shift is negative pi over 4. That's not a vertical asymptote, is it? That's right there in the middle of your period. So what would you have to do? Think about it, and you just did it. What would you have to do to find one of those VAs? Find a half a period and add it either way, or add it or subtract it. So you go and find your period, which is pi over 2, half it, which would be pi over 4, right? And then just add a pi over 4 to it. So you can see the phase shift is right there at 0. x equals 0, right? Or you can subtract the pi over 4 and get, all right, negative 2 pi over 4 or pi over 2. And look, there's a negative pi over 2. There's a vertical asymptote. So I have asked that every year in its existence, if you want to star that or put it, where I give you something and say, find one of the vertical asymptotes. And sometimes I'll do that on a cosecant or secant graph as well, but we haven't gotten there yet. Not too bad? Now we're going to graph that cotangent one in a second, but let's just pretend for a second that this was a cotangent. So I'm going to erase all this and then we'll go graph the cotangent one. So don't change this on yours, but just to give you a little preview of all, this. So let's just say you had marked the D value, marked the A value, found the phase shift, right? We said the phase shift was negative pi over 4, and you found the period was half a pi. So let's just pretend for a second, if this was a cotangent, would the D value be any different? No. Would you mark the A values any different? No. Would you find the value of the phase shift any differently? No. Would you mark it any differently? Yes. So in this one, at pi over 4, instead of putting an arrow by it, right? Or because the phase shift is in the middle, now on a cotangent, the phase shift is back to being the beginning of the period. That's the phase shift. So in this case, you can go ahead and make it an asymptote. You with me? So on all the trig functions, when you find the phase shift, that's the beginning of your period except tangent. So on this one, I'm going to go, oh, it's back to being the beginning. Now you don't have to do this on yours because I don't want to mess up your tangent graph. But if it was a cotangent, it's still in the same place, it just means something different. And then in this case, you don't have to go half a period each way, do you? Because it's at the beginning, you go a full period to the right, another full period to the right. You're still going to mark the middle once you get there. Sorry, I don't need that. Yeah, I don't need that. So you mark the phase shift, go one period, and then you're still going to go to the middle. But this time with positive cotangent, would you be all right to be tan? No, you're going to go cotangent to the left. But the same thing. If I'm going to the left, I'm going to go half the way up, half the way down, and sketch the same kind of looking thing. Half up, half down, and that would be a cotangent. So, from the beginning, I guess, let's just look at that cotangent. And if you can do those, I think you're home free, really, and you'll see that the secant and the cosecant are not much different than sine and cosine. You just basically graph a sine and a cosine, and there's just a small, well, not a small, the graph looks totally different, but a couple of little things that you do each time. All right, so check it out. Here's cotangent. What do you do with the 1? That's the D value, so I'm going up 1. That's my vertical shift. And what do you do with the positive 4? It's my A value, whether it was positive or negative here, I call it positive. Up 4 from the D. Down 4 from the D. What's my phase shift? So if I set the x minus pi over 3 equals 0, I get x equals. Now pi over 3 means what to you? You're going to go what to find it? 1/3 of a pi? And pi is how much right here? 6. So what's 1/3 of 6 ticks? So you're going to go 2 ticks, and you're going to mark that phase shift right there. And for a cotangent, like all of the other ones, the phase shift marks the beginning of the period. So I'm going to go ahead and mark that with a vertical line because it actually is a vertical asymptote. All right? And then what's the period here? The length of the period pi over 1. So in this case, just pi. And pi is 6 ticks. And so since pi is 6 ticks, I'm going to go 6 ticks to the right. Another VA. And I don't have room, so 1, 2, 3, 4, 5, 6 ticks to the left. And my ladder has really wide rungs now. That's okay, isn't it? So what do? I've got everything set up, right? Point dead in the middle, so in between the asymptotes, middle rung. In between the asymptotes, middle rung. And it is a positive cotangent. So positive tangents up to the right, cotangent, positive cotangents up to the left. So how do I mark that one out to the left? Halfway between here and here, I go up. Halfway between here and here, I go down. Same thing on the other one, halfway up, halfway down. And then I'm going to just follow the asymptotes with a smooth curve. And if I would have asked you to find one of the vertical asymptotes of cotangent, what could I have just used? I could have just used the phase shift, which is what I found, pi over 3, right? When I set that equal to 0. So on this one, if I was to find a vertical asymptote, I wouldn't have to take it and add a half a period or anything. It's just the phase shift. I could totally add another whole period to it, or subtract the whole period. What are we thinking? Feeling all right? All right, that's sine, cosine, tangent, and cotangent. The last two, the secant and the cosecant. If you can graph a sine and a cosine effectively, there are two things you do to graph the secant curve from the cosine and the cosecant curve from the sine. Because they're reciprocals, they are related that way. So let me show you. And I'm not going to make you go through, at least on this practice little session, graphing the whole cosine curve. So I went ahead and graphed it for you so we can focus on what you add to it to make it a cosecant. All right, so this is a sine curve. Now, it might have been a cosine curve that was shifted or whatever, but we're going to pretend that it says if this was a positive sine curve, so a positive sine curve meant it bumped up first and down second, maybe that was the box right here, okay? So maybe you come in here and mark the D value, mark the amplitude, mark the phase shift, added a period over, and you got to here, all right? So you're feeling pretty good about yourself. And again, this is sine. So what if I now tell you that, oh, it wasn't sine. It was actually a cosecant curve. So you were actually graphing this. Maybe, what would you have been? Up to +3 cosecant of some bx minus c, okay? So you came in here and you graphed your positive sine curve, you got it all labeled in here. And let's just say you even had 2 periods in it, which we of course have all the periods that will fit in this region. The only 2 things you have to do are these. Wherever your sine curve would have hit the D, which is that middle line, that's kind of where your sine curve would have been 0, right? Because a regular sine curve starts at 0, hits 0, comes back to 0, right? Well, if a sine curve is 0 there, what would happen when you flipped it? What happens when you flip a 0? It's undefined. So what do you think the cosine of the cosecant should look like at these 0 values? Vertical asymptote. So all you have to do, does that make sense? On a normal sine curve, if you were graphing a normal sine curve, sine of 0 equals 0, sine of pi equals 0, sine of 2 pi equals 0. This is where a normal sine curve hits 0. Well, if a normal sine curve hits 0 on that D, when you flip it, a cosecant curve would be undefined there. So any place it hits that shift, that vertical shift, you're going to place a vertical asymptote because the cosecant curve will not exist there. So there, there. So this is what you'll do differently. You'll graph that sine curve on there, and then you'll just come in here and put a vertical asymptote at every place the graph hits the d value, or the line y equals d. Now I want you to think like this. Well, the how of this is pretty easy, but like, if sine was equal to 1/2 somewhere, what would be cosecant? What would cosecant equal at that 1/2? 2. So it's basically taking reciprocals. So places where the graph would go up a half are actually going to go up 2. Actually, this is not a half. This would be like, and places where it goes up 2 are going to go up even further. It's going to magnify those values because you're taking reciprocals and fractions and turning them into whole numbers. Are y'all with me? But right here, the only thing I do to actually do this is I put points at where the relative maxes and the relative mins are, the little high and low spots, and I just draw parabolas. They're not parabolas, but parabola-looking things going up or down from those spots. Now what happens if you just draw the parabola things and don't draw the asymptotes? You're probably going to end up crossing where the asymptotes should be, and if you do that, you're going to get dotted or whatever. So we're not going to get overly picky about how those look, but we are going to make sure we put the asymptotes and then sketch them in there. Now what is the actual graph? Is it what I've just done here in the brown, or is it the brown and the purplish that's in there? It's just the brown. That's the cosecant, right? So here's what I would encourage you to do. When you're graphing a cosecant or a secant, put your sine or your cosine curve in there with a dotted line. And remember, dotted lines are not on the graph. That's why we put vertical asymptotes and dotted lines. And that will show you that you're using those values to help you sketch it, but it's actually not part of the graph, other than those high and low spots. Not too bad? And the exact same thing happens with secant. If I ask you to graph a secant curve, you're going to graph a cosine curve. So like for instance, if this was a positive cosine curve right here, if it was, here's your positive cosine, maybe your box, or at least one of the positive cosines. Maybe this was your box, where you went from high to high. Maybe here's another box, from high to high. That's what you would have done if this was a positive cosine curve, right? But if it is a y equals -3 plus 2 secant bx minus c graph, you're still going to graph a cosine. You're going to graph a positive cosine, but you're going to put it in as a dotted line. In fact, some people go, do I even need to put the dotted line in? Don't I really just need the points? And the answer to that is yes. That is really all you need, because the points that you've been marking are the ones that you're going to be using, right? But you're going to do the exact same thing. So what do you do with the values that are on the D? Those are places where cosine was 0. So what do you think happens to those when you turn it into a secant? That's where the secant graph becomes undefined, yes. Undefined, so I'm going to put vertical asymptotes there, and there, and there, and there. And then what else do you think you're going to do? If this is anything like a cosecant graph, draw the little parabola looking things, right? So any place where it's low, any place where it's high, low. And if you're only graphing 2 periods, we still got those little 2 halves on either edge. We'll just graph a half a period there and a half a period there, or go further and extend it if you want to. But that would be 2 full periods, right? Up, down, half up, down, half up, half up, down, half up. Now here's how I could mess with you on a test. I could give you this secant curve, and I could ask you, where are the asymptotes? Or give me one asymptote, the value of it. And you know it's x equals something because it crosses the x-axis. And what do most people do they make a mistake? They go, oh, and they find a phase shift. Like this ends up being pi over 8 maybe or something. So they go, oh, phase shift is pi over 8, so x equals pi over 8. That must be a vertical. But it turns out at pi over 8, that was not a vertical. That was the edge of the box. But where was the vertical asymptote? On either side of that. So you tell me, what did I really do? Think about this phase shift. That's a phase shift right there. What did I, and this could be a phase shift too. It doesn't matter how. You would probably have found that one. You might have found that one. Whatever. Let's just say you found that phase shift was pi over 8. And you went 1, 2, 3, 4, 5, 6, 7, 8. Pi is 8 ticks, so I'm going to go 1/8 of a phase shift. But that's not the vertical asymptote, is it? That's just my shift. Where are the asymptotes located? Think about a period. Now you can, it's funny how you guys graph this and you do it robotically, but you're not really thinking about what you're doing. If that's a phase shift, how did I find the end of the box? What did you do? What do you do with sine and cosine to find the end of the box? You find the period, right? So you just added one period to the right or to the left. Where is the asymptote located on this secant graph? How much of a period over? If this is a whole period, be generic. What part of the period did you go over? 1/4 of it. You could have also gone 3/4 of it, right? But you went 1/4 over to get the period, because if you break a period into 4 parts, that's where these points are, at halves and at quarters, right? So just add 1/4 of a period and you hit an asymptote. Now that's not the way it works on a cosecant graph. You saw that on a cosecant graph. What happened? Yeah, the asymptote was right there on the phase shift, but not on a secant graph. So if it helps you to sketch a secant graph and go, oh yeah, secant is a cosine. You know, cosine does this. Oh, so my asymptote was 1/4 of the period over. I need to add 1/4 of a period. So if that's what you do for like if this was a secant, like this. But if it's a cosecant graph, like we did before, the asymptote is the phase shift. And if you need to sketch it off to the side a little, make a little box and think, what would I have done here? But yeah, you could, once you have that box in there, here that the asymptotes occurred at 1/4 of the way over and also 3/4 of the way over. Or 1/4 either way when you look at the picture. Y'all with me? And then couple more maybe. What if I gave you a negative? And by the way, I'm really doing more than you need to. Like if I had given you this on a test, does it really, if I asked you to sketch the cosecant curve, does it really even matter whether I tell you it's a negative sign or a positive sign? No, because every one of these you're going to go, where was the D? Right here in the middle? Right? So really I can go, okay, it's undefined there. Once I get this thing figured out, it's undefined there, and at the bottoms, curves down, the tops, curves up, etc., etc. I can do the bottom one, but I think you're probably in good shape, aren't you? And guys, that's graphing sine, cosine, tangent, cotangent, secant, and cosecant. So you've got 11 minutes in here if you want to work on your homework, which is probably the tangent and the cotangent, secant, the cosecant stuff. I think I may be giving you one of each on that worksheet. What is it? Worksheet 6 maybe? Or 5 or 6. If you want to work on those, and then tomorrow, I'm going to go backwards. I'm going to give you an equation. I'm sorry, instead of giving you an equation and say graph it, I'm going to give you a graph and say find the equation. But I think you're probably already going, is that a whole lot harder? Not really. It's a little bit different thinking because you're going backwards, but most people have pretty easy time of that, with the exception of maybe some tangent graphs I could sneak at you. And we're kind of winding it down. So all we have this week is, finding the equations from the graphs. You're going to start your review sheet. We're going to have an optional, like if you want to jump in on Wednesday on a meet, then you're supposed to email me a time. Just pick a time on that slot, fill it in, and I'll meet with whoever's on that slot. If you have questions and need answers or whatever, and then we'll start our test on Thursday. So fairly slow week in that regard. And that may, word on the street, it's not really a word, but I've been like reading in between the lines, that may be our last meet day. What I've been sniffing out, I know that you guys on the PSAT day will come to school. So that meet day thing is gone, that Wednesday, although you are off that Friday. Because parent-teacher conferences, so you guys won't even come in at all on Friday. So it'll go red, blue, Monday, Tuesday, Wednesday, Thursday. And you guys will be here basically a half day. So you won't see me on that PSAT day because you'll come in you'll be taking the PSAT all morning. Well, you might see me if I'm in testing in your room. But you'll just go to 5th, 6th, and 7th period. So you'll have to go home and watch a video from that day. But that might be the last day we're doing this red-blue thing. I may be wrong, but it's either going to be they throw all you in here on a Wednesday as a trial run, or they throw everybody in here Monday, Tuesday, Thursday, Friday on a trial run, or they say, screw all this, we're sending everybody back. And that's kind of what I'm thinking is the lean, but they're supposed to meet with health officials today, tomorrow, whatever, and figure all that out as recommendations for what to do.
Send us all back to virtual?
Say it again?
Send us all back to virtual?
No, send you all back at once. So
Okay.
you would be joining the other half, that you'd be with the blue people.
Well, I know, Shelby County, they're all like that. Like,
They've been back for a couple of
everybody-
weeks, yeah.
Yeah, and I mean, I don't think they've gotten it's been horrible.
It hasn't. I just talked to a girl who's a senior over there and her parents, and they said they had 70 kids that were out, and those didn't all have COVID. It was like contact tracing and all that.
Yeah.
So I'm sure though, the only difference will be if you get it, nobody's going down with you in this class.
Mm-hmm.
But if everybody came back, 5 people would go down with you in every class. But we have yet to have somebody get it through the tracing. So everybody we've sent home for tracing, none of them have gotten it. So that bodes well for, as far as this is working, I guess, the mask thing. I mean, it's not working for me, but it's working at some level. So that's my feel. I haven't heard anybody say it yet, but I've read between the lines a lot. So that's my guess. All right.